Efendim sırada yine gayet teknik bir sunumumuz var. Sevgili Kazım Bozkurt Innovera'dan yapacak bunu. Peki ne yapacak? Software Composition Analysis Demo. Yani yazılım değil mi? Kompozisyonu, analizi, demosu gibi bir şey. Bu açık kod, açık kaynak kod güvenliği ile alakalı bir demo galiba. Ama ben şeyi çok şiirsel buldum. Yani açık söyleyeyim, toplantıdan sonra girlfriend'imi arayacağım ve bunu söyleyeceğim. Bunu bir kere de söyleyebildiğim için büyük ihtimalle kız bana tekrar aşık olacak. Software Composition Analysis Demo. Bravo Kazım Bozkurt. Yemin ediyorum ki yani şunu çıkıp da çatır çatır yapmak hakikaten çok büyük maharet. Zevkle izleyeceğiz, seyredeceğiz, dinleyeceğiz kardeşim.
Hello, dear guests. Today in this session, we are together with David from Sonatype. He's the partner solution architect, and he will give us a very precious presentation and a demo session. Please go on, David.
Hi, thank you. Let me share my screen first. Okay, so hopefully everybody can see my PowerPoint. We're going to talk a little bit about how we can orchestrate open source security as part of your software development lifecycle using the Sonatype platform. So my name is David Doughty. I'm currently Partner Solutions Architect at Sonatype, working in EMEA with our partners across the European continent. I've got a varied history across IT. I've been in IT for a little over 30 years, from development all the way through to configuration and release management, and have worked in several of relatively familiar organizations across banking and telecoms, deploying tooling similar and the same as the Sonatype solution. So I have some real world practical experience of deploying these technologies into what was tooling is now DevOps or DevSecOps, depending on how you term them. So I'm going to do a little review of the Sonatype solution and who Sonatype are and where we fit into the software development lifecycle, based on assuming that you have at some point listened to my colleague's presentation previously. Most modern applications are constructed rather than developed from scratch, which means that most are made up of 80+% of code that's sourced from external suppliers, whether that be from Maven Central, from npm.org or pipei.org, or one of the many other ecosystems available to our developers, which kind of suggests that we have some form of supply chain in our software development, even if we don't call it like that. So rather than build our applications from scratch, we actually construct them from these open source components and maybe glue them together with our own proprietary code. So we get the code from our suppliers, open source projects, organizations such as the Apache Foundation, etc. Although there are an awful lot of very small open source development projects that don't operate under the Apache banner. Those components are delivered and consumed through warehouse, much like any other manufacturing process. In the terms of software, these are component repositories. So something like Maven Central or npm.org would act as a public repository, and something like a proprietary repository manager product, which we'll talk about in a little while, would operate within the organization to allow you to manage your own open source and inner source data. That then feeds into our manufacturing process, our software development teams, who would then put those components together to generate our finished goods or our software applications. So even if you don't call it a software supply chain, it's very similar to any other supply chain in any other manufacturing or operation. So what Sonatype promote is the application of recognized supply chain management principles that were originally kind of developed by a gentleman called William Edwards Deming and applied through the Japanese automotive industry in the late 40s, early 50s. So we'll talk about that as we go through the demonstration. So, given that we're now using open source commonly across the development of our applications, there is a need to review those components for new releases, new security vulnerabilities, to understand the license information associated with them, and to validate the component provenance, so you know that you're actually consuming components from a trusted source. So you're not actually just downloading the first thing that comes to the top of your Google search. And while we were in the very early stages of using open source, that was relatively easy for a developer to perform manually with a limited number of components and a limited number of ecosystems to have to manage. However, over the last 20 or so years, the volume of components, new components, updates to existing components, different ecosystems, new ecosystems as we progress from just Maven or C or C++ through to Go and the like. It makes it much harder for an individual or even an organization to actually track all of this change, to understand what new versions exist and what security vulnerabilities exist. And that's coupled with regulatory requirements. So we're seeing an increase in the regulatory requirements across all industries, but particularly when it comes to Europe with GDPR and the like. We have to be able to start to demonstrate that we understand what open source issues we have and that we mitigate them. Otherwise, we run the risk of breaching our regulatory requirements in terms of data protection and the like. So as I say, this is very, very difficult for an individual organization or even an individual developer to actually perform independently. So Sonatype actually operates a mechanism that allows us to identify open source components across many ecosystems. So we examine all of the public repositories, Maven Central, npm.org, pypi.org, etc. We ingest all of the components, the versions, to be able to identify what public components exist. And then we go out and find security information. So many people cite the National Vulnerability Database as the gold standard of security issues for IT systems. And that's true. They do have a significant number of issues that are recorded centrally. However, not everybody issues their security vulnerabilities via the NVD. In a lot of modern open source projects, they work in GitHub. They take advice from their consumers, their users, to identify a vulnerability. They'll investigate, and if warranted, they'll patch it and release it and move on. And they don't then notify the National Vulnerability Database that this issue exists. And the only way that you as a consumer would find this out was if you would actually go to the GitHub project, look at all of the commit notes, and to be able to see what security vulnerabilities had occurred. So Sonatype literally do this for you. So we identify security events and security kind of highlights across multiple inputs. And we examine every GitHub event for anything related to security. We look at third-party security advisories coming from third-party security teams that may highlight particular vulnerabilities in particular open source components. And all of that information is automatically gathered and associated with the open source components that we identify from public repositories. And that then feeds into our Sonatype research program. And we have human data scientists that actually then curate the security information. They actually look at the vulnerabilities. They determine if it's a real vulnerability or not. And if it is, Then they'll do a deep dive to identify what the actual threat is, where it exists, and provide a detailed explanation to our customers as to what the vulnerability is and how to remediate it. And that's obviously some of the value that we bring in terms of the technology is this massive database of vulnerability information, among other things. So how do we bring that to you? So obviously this requires injection into the software development lifecycle. So we automatically enforce policy across all of the phases in your software development lifecycle through the bringing in of open source components, which would typically come in via repository manager. So you would identify your trusted sources, so Maven Central, etc., and that would be your repository manager would be pointed at those trusted sources, so that you didn't accidentally bring down components from evilhacker.com, for example. Now that would then present all of your staff with, or your development staff with, trusted components from trusted sources that they could consume and add into their applications. But that's only kind of part of the problem, because many open source components are known to have vulnerabilities. And if you look at the OWASP top 10, their A9 reference is don't use known vulnerable components. So we're able to help you identify those known components once they've been brought into the organization. So the Nexus Repository Manager provides this central kind of point for consuming components, but also for publishing your own inner source to share between your teams, and the finished applications to be able to deploy them into your different environments in a constructive, a controlled fashion. In order to help manage the ingestion of those components, we have a Nexus Firewall component. The Nexus Firewall is really using the data provided by our hosted data service to identify those components which have a significant risk in them. It can run in either an audit mode or a quarantine mode. So the audit mode really gives you a list of those threats. And the quarantine mode allows you to block those components which exceed your risk profile. So maybe you want to block things with a critical vulnerability. It will allow you to stop those things being downloaded into your organization before you start using them. But assuming that not everything's got a critical vulnerability, we need to understand what information, what open source exists within our applications, and understand what threats or risks are associated with them, because not everything is a security issue. We obviously have to consider legal compliance when using open source components, depending on how we deploy our applications. So we deploy the Nexus Lifecycle product, which allows you to instrument your software development lifecycle to expose teams to the open source risk within the development lifecycle, rather than having to wait for a security team towards the end of the development cycle, get a list of security vulnerabilities and then feed that back. And maybe you have to then go live with a significant amount of risk in your application. So lifecycle is really about trying to expose that kind of risk early in the life cycle, so that you can mitigate that risk before going live, without having to rely on a single point of inspection as part of the go live process. And all of this is powered by the data services that I talked about a second ago. Okay, so being able to identify the risk is great, but we want to be able to kind of present that in a consumable fashion by our software development teams. So rather than just rely on Sonatype providing a dashboard with a list of issues, we actually instrument the integration of multiple tools across the development lifecycle, allowing you to consume the open source threats in the tools that are appropriate to you, the tools that you use through your day-to-day activities. So through the IDE, providing feedback to the developers, through the CI system, because everybody uses some kind of continuous integration engine to be able to build and to expose the testing results. but also integration into your source code control system. But depending on how you work, one or more of these may be appropriate to go forward. So what we're going to look at in the demo is being able to kind of see what we can expose when in our software development tool. So we're going to move over to our presentation and into our demonstration. If I get the right thing to share. Okay, so before we go too far, let me get rid of that toolbar to my way. So we're currently looking at the Nexus Iq Server. So at the moment, I've kind of mentioned multiple tools: Nexus Repository Manager, Nexus Firewall, Nexus Lifecycle. So the products which provide the open source feedback are the Nexus Lifecycle and Nexus Firewall tools. They're both products which rely on the Nexus Iq Server to be installed, and they effectively enable particular functionality based on the Nexus Iq Server. Now, the Nexus Iq Server itself is very important because it's effectively a policy engine. So it allows us to create rules within the product that allow us to highlight particular threats in our open source code. So, as we can see from the tool, we have a list of policies that come out of the box, and we have a series of actions that can be performed at different points in the software development lifecycle for each of the rules. So depending on which rules we want to apply, we can change the behavior of the integration into the software development lifecycle. We'll look at that in a little while. So I mentioned briefly that security is not the only issue with open source. So we actually provide feedback on both on security, legal, architectural, and other aspects of open source, because we want to be able to allow teams to prioritize which is the most important thing to address. So we rank the threats appropriately, because it could be that a license threat has more implications for the business than a security threat if it's a relatively low level CVSS. So licensing and security are somewhat different. So a security issue, a security event is normally dictated to by a global standard, which is the CVSS scoring system. It runs between 0 and 10, and it basically provides a kind of threat level running between 0 and 10 that highlights how severe the issue is. So it's fairly straightforward and easy to understand. 0 being not a problem, 10 being a significant issue. It's the highest threat level you can have. So licenses are a little harder to to understand the threat that they bring to the business. So the way the Sonatype address that is using something called license threat groups. And if I do that right, so license threat groups allow us to take licenses with similar obligations. So obligations are the things that you have to do under the legal agreement you take with the vendor of the open source component, and these vary in their demands, so to speak, from what we would term a banned license, where they're very restrictive or they have very restricted provenance, all the way through to liberal licenses, which tend to have no restrictions other than maybe recognition in your release notes to say we've consumed this component. It's developed by individual A, and you get some kudos from that use. And in between them, there's a load of commercial licenses and other licenses with different obligations, which we've categorized in a certain way. Now, obviously, your legal team may have a different take on that. They may want to separate it out, but the threat groups allow you to say these licenses have similar obligations and are restrictive, i.e. banned, and these licenses have no limited restrictions. They're free for use. And that then allows us to associate a threat score with a license as well. So when we're running our policies against an application, your license policy. As a developer, you're presented with a series of threats. If a license 10 is at the top, then that's obviously the highest problem. If you've only got a security 2, that's a relatively minor issue. So you should focus your attention on the license issue, if that's within your requirement. So these policies can be applied differently depending on how applications are used, how you deploy applications, etc. So we can categorize our applications based on typically on distribution. So if you're sending something to a customer, licensing is very much important. Whereas if it's deployed internally or it has no customer data behind it, it has limited. There's a much lesser requirement for reducing the risk profile with it. So you don't spend a lot of time and effort, or you don't need to spend a lot of time and effort resolving problems with applications which don't necessarily need addressing. So that's the basis of the IQ server. So we're going to look at how we expose developers to the information. So this is usually done through a CI system. It's by far the most popular integration point. It also helps us perform some of the automation that I'll talk about in a little while. That we can automatically resolve some of your problems without actually having to have a developer do a lot of investigation and manual effort to figure out what the results are. But let's go ahead and build this application. It's obviously a deliberately a vulnerable application, so it has some well-known vulnerabilities in it. I obviously built it beforehand, so I've got the dependencies locally, so I don't have to spend a lot of time pulling them through my repository manager. But you can see we've successfully built the application. And then we're going into the scanning phase. So the scanning phase, and this is one of Sonatype's unique selling points. Scanning an application allows us to identify the components that you're using when you're going into production. So we're not interested in your development artifacts. We're not interested in what you're testing or instrumenting as part of a test cycle. We're only interested in the application that you're going to deploy into production, and therefore the libraries and components that are going with it, because that gives you a true view of what risk you will run when you're in a live operational environment with this application. So this is Java application. So it has a WAR file. So we scan the application and its content. So we will scan the WAR file. We will scan and we'll create a hash for that WAR file. And then we'll scan each of the files and folders within the WAR file, and we'll create a hash for these. And inside those components, we will create hashes for all of the files and components and folders within them. So each of these are obviously libraries, but within these jar files or class files, HTML files, etc., etc. So we build up a picture or a fingerprint of each of these libraries that is unique to this library and the version of this library. And this scan file is what we use to provide a reference for the policy engine. So the scan file is taken as part of the client scan, which is in Jenkins at this point. It then goes to the IQ server. The IQ server then communicates to our data services, which then processes the hashes to identify which components are open source, which components are the components you've developed. Obviously, we know nothing about those. And then provide the feedback, what security issues exist with it, what legal obligations are associated with it, age, etc. Some additional architectural metadata. That information comes back to the IQ server, and it's then processed against your policy. Now, I'm using a standard set of policies that then will generate feedback to highlight good, bad, or indifferent components based on the intelligence that we provide in that feedback loop. And as you can see, our Jenkins job has started to highlight some of the issues that we have with this particular application. And It is a deliberately vulnerable application. You may or may not get quite so many if you were to scan your applications. So at the end of the scan, we've got a bunch of warnings, and our application and our build, being Jenkins, is now unstable. So there's a couple of additional things going on here, which I'll explain in a little while. So we can look at the report, because that's really what we're interested in. Let's close that window. So what we get out of our scan is a bill of materials. So this is much like any other bill of materials for a car or a washing machine or TV. It's a list of the components that you use to construct your application. In this case, we are highlighting those components that have risk associated with them. And we have 13 components, and we have somewhere in the region of 54 violations across those components. So as I've just clicked on the All Violations button, you can see that some of these components have multiple issues with them. Okay, so it's useful to know this. So the bill of materials is kind of the starter for 10 as far as software composition analysis goes. Where do we go from here? We need to understand how we can remediate these issues. And there's obviously a couple of ways of doing that. So if we look at a particular component, we get a lot of valuable feedback about what version of the component is, how popular it is, where threats exist, where threats don't exist, etc. We get to understand what the legal options are. So in this case, this is highlighted because it has an AGPL 3 license, that has a very restrictive provenance on it, to the degree that you cannot use it for commercial purposes. So unless you have a commercial agreement with the vendor, it also has a security risk associated with it. And if you want to look at the security risk, you can see some of the expanded data that Sonatype provides as part of the product. As part of our data research, we go through and go through the application to understand what the problem is, where the problem exists, in this case in the shape of multiple class files. Now this is important because generally in open source, there's a lot of reuse. People borrow and use code from different libraries, etc., or a developer will move from one project to another, and they'll take their experience and or code with them. So what this means is by identifying the root cause, we can then identify if any other systems are using these class files, and because they would be subject to the same vulnerability. So that would be an additional valuable kind of piece of intelligence that nobody else in the industry can provide. And there's obviously a bunch of advisories. So these are typically third parties that provide details. They're security focused. They go for bug bounties, etc. And they when they find a bug, they'll document it. They'll provide details of how to use it, how to exploit it, how to remediate it, etc. So Sonatype use these people as a data feed to be able to kind of help provide that information much more consumable fashion to our customers. So that's the kind of vulnerability information, which is great. As a developer, I can take this and I can apply it to my application. Still requires a little effort on my part to understand it, to then understand if we are vulnerable, etc. And it's a bit of a pain to have to go through another UI to be able to find these things out. So the focus of Sonatype is to really make this information much more consumable to our development community, because ultimately, if we can get the developers to resolve these problems earlier, then it saves a significant amount of time, cost, and effort to fix them if we have to leave it till the end of a particular project. So this might be where I need to do another share. Kazim, can you see my Eclipse IDE? I would guess not. Hold on a second.
Right now, I can see the Nexus Iq Server.
Yeah, okay, I need to share something else. Share Eclipse. 2 seconds. Okay, so you should be able to see my Eclipse workspace. So the IDE integration it's been around for a while, but this allows us to highlight some of the issues much earlier in the life cycle. So if we look at the component information, you'll see that we get a similar list to what we had in the UI. But in this case, we've got it in what we as a developer we use to be able to construct our applications. And we can see that we've got components. We can see the information that we have associated with them. We even get some guidance on how to upgrade, on what version to upgrade our component to mitigate this particular risk. So what we're going to do is we're going to take the component and we're going to upgrade to be able to remove some of these threads. So I'm actually going to move it to 525. Save that and commit. And as you can see, I haven't even committed the change yet, and all of a sudden the ID is actually refactored. Let me just finish the commits. Commit and push. Okay. As you can see, the ID has refactored the component list, and we're now down to a much lower level of threat in our application just by changing one command. Now, obviously, this is a demo, so it's designed to do that. But yeah, just to show that by changing a single component, you can actually improve the hygiene of your application significantly, because it actually what we did just there was resolve not only the direct dependency, we actually updated a bunch of transitive dependencies, which are dependencies of dependencies that we didn't necessarily know that we had. And we can go further. We can actually update some of the other components as well if we needed to. But obviously, as a developer, our main focus should really be on business functionality. So we're going to move on. We're going to make changes to create new features, etc. We're going to leave other issues to the security teams. So we're going to go back to the browser.
We have 10 minutes, David.
Yeah, that's okay. So we committed our change. So we've resolved some of our security issues. We're going to rebuild the application to pull down the commit. It's not pulling everything from the internet, so it saves a great deal of time and effort. So we're scanning the application again. And you'll notice that, eventually. We still have some issues, but we don't. But it's nowhere near as long a list to deal with. So if we look at the report again, we only have some very minor. We're down to a much more manageable number of issues. Now, if we were following a standard release cycle, we build, we promote the application to testing, promote it into live. To save a little time, I'll kind of talk that through. So what we would typically do with the IQ server is, as you promote the application, you would also take the report, the bill of materials report with it, so that actually they come as a couple. Now we can do that in Nexus Repository Manager because we can annotate our repository manager and our build artifacts with reference information, so that we can understand what the report is, what the bill of materials is, what other metadata that we need with our application. So who approved it, why they approved it, why it wasn't approved, etc. So we can move the application in Nexus Repository Manager through different stages and present at some point a gated process that says, well, if you get as far as release, if you haven't resolved all of your critical issues, then we're going to stop you from deploying the application. So we haven't got too many critical issues. We've only got one level 10 left, and that's a license issue. So, so obviously the obvious solution is we want to take the license issue out. So changing the component may not be practical at this point. So if we're going through a process of agreeing that we can use this component, we can actually introduce what's known as a waiver. And we can annotate this to say, project manager is with the vendor on a commercial agreement. So, which would allow us to use the actual the library in our production code. So that waiver then effectively removes the license band issue. It doesn't go away, it's just waived. We've acknowledged that this risk exists, but we're going to kind of move forward. So that gives us a much cleaner business, which ultimately is the aim. We want to be able to take all of the threats that we have in our application and mitigate as many as practical, whether that's by resolving the component, removing the component, changing the component, upgrading the component version, or just creating a waiver that says, yes, we know we've got a problem, however, it's minor or it's not applicable to us, then we can do so. But ultimately, the aim is when we go to production, we have a clean build in the terms of our software composition and analysis. So, and that way we can ensure that in the future our application is not going to cause us any problems. We're not going to have any security issues. Therefore, there's no data breaches, etc. So I appreciate that we're kind of running on the last few minutes of the presentation. I guess I'll come to a close at that point and come back to Kazim.
Thank you very much, David. It was a precious presentation and the demo. I have some questions about your presentation.
Sure.
Integrating throughout the SDLC focuses attention during development. How do we identify new vulnerabilities once an application is in production?
Okay, so what you're asking about is how we deal with zero-day attacks. So these are typically attacks that come and new vulnerabilities are declared. So once we have a bill of materials for our application. So the bill of materials would, as we promote to live, the bill of materials would go with our application. So it would move through this life cycle that we have for our policies. Once it's in operate, then you can start applying something called continuous monitoring. And continuous monitoring really allows us to stage independent. It really allows us to say, well, we have this bill of materials, which we know we've done a good job. We've cleaned our issues. We've removed all of the vulnerabilities that we know about. But continuous monitoring allows us to reevaluate this report to identify any new vulnerability. So every 24 hours, the continuous monitoring basically resubmits the report to the Sonatype data services. So when we ingest new security details, if it's appropriate, if it's applicable to one of your components, you will get a new vulnerability in your application. And as part of the continuous monitoring setup, you can generate a notification, depending on which policy you want to highlight. You can do a continuous monitoring notification, either an email or a webhook into Jira, or maybe a proprietary webhook into another system that would generate some kind of notification to your team to be able to kind of remediate the problem. Because we know there's a very short time span between vulnerability being declared and active exploits occurring in customer environments. So you have somewhere between 2 and 3 days to address these problems. So continuous monitoring gives you that alert. As soon as we know about an issue, you can go fix it, redeploy the application, and you're safe and your customer's data is safe.
So we can extend the Sonatype protection above the development, right?
Exactly, yes.
Okay, thank you very much. And I have one more question. Supply chain attacks are becoming more sophisticated. How can Sonatype help in this sophisticated attack model?
Okay, yeah, so the traditional kind of attack vector comes from open source projects performing their due diligence and telling the world that they've a problem and that it's been fixed. But what we've seen in the past 2 or 3 years is much more proactive, malicious intent from third-party attackers, actually taking over credentials or identifying credentials that have been mistakenly advertised publicly, or joining projects and assisting a project and then injecting malware. So Sonatype have developed some technologies which is available through the Advanced Developer Pack, and that allows us to perform a release integrity check on open source components. So it's much like a profiling system. So it profiles the commit behavior of projects, and then we use artificial intelligence and machine learning to identify if there's anything strange going on with an open source project. Maybe has a new committer started working with a project. It may not be malicious or anything like that, but it highlights that there's been a change that maybe you want to know about, to be able to highlight suspicious behavior within a particular ecosystem. So this kind of release integrity acts as an early warning system. So you can build policy to say, if an artifact is suspicious, Sonatype thinks it's got some strange kind of behaviors associated with a new release, etc., then you can actually build policy to prevent those components from being ingested or used within an application. And this is so we highlighted this recently towards the end of September, and there's a blog post on our website that highlights some npm packages, Electron, Load YAML, etc., that were removed from npm.org that exhibit this behavior. So they're typo squatting packages that allow you to inject. We're injecting some malware to extract data from user systems, IP addresses, names, etc. So it's already started to prove its worth in the wild.
Thank you very much, David. These are very beneficial information for us. We come to the end of the session. I also thanks to my guests who attend this session and follow the session to the end. Thank you very much, David.
Thank you very much, Kevin. Hope everybody has a good day.
See you. Bye.
Take care. Bye-bye.